Good morning and warm greetings from IIT Kharagpur. My name is Anandarup Bhattacharya. I am a faculty of Mechanical Engineering at the Indian Institute of Technology Kharagpur or IIT Kharagpur. And today I am here to talk about one of the courses that I have offered under the NPTEL MOOCs platform named Electronic Packaging and Manufacturing. So, I think the first question, let us spend a little bit of time on what is electronic packaging, because this term packaging can be a little misleading. Many people may think, is it like taking an electronic product and putting it in these cardboard cartons and boxes so that it is protected while shipment? Unfortunately or fortunately, that is not the case. Packaging is a very vast field and it is not easy to define it in a simple sentence, but let me try to tell you, or let me tell you that packaging, if I may call it so, is the science and technology of protecting and interconnecting smart or intelligent devices. So, what do I mean by that? If you think of, let us say, one of your computing platforms, whether it is a laptop, whether it is a desktop, whether it is a tablet or even your smartphone, we have got these devices, the CPU, the graphics, the memory. How do you connect these semiconductors? How do they communicate with each other to give you the final user experience that we all desire, which is the reason why we bought that product? So, the science of taking these semiconductors and converting them into a finally useful and usable product, that is what largely packaging is about. Remember, I also said it is about protecting. Now, what is it? What is the protection from? This is also about, then that brings us the concept of reliability. My device should perform as per my expectations, not just today when I buy it, but also maintain its performance over the period of its useful life, whether it is 3 years, 4 years, 5 years. Because during its operation, during its usage, it is subjected to abusive environment, if I may call it so. It is subjected to mechanical stresses, it is subjected to heating, because heat will be generated and that heat must be dissipated so that the temperatures are kept within the limits. So, this whole concept of reliable performance over its period of useful life also forms part of packaging. Okay. So, as part of this course, what we are going to talk about is primarily focusing on the mechanical, manufacturing and materials challenges. Okay. We will start with a little bit of introduction of what packaging is and a little bit of wafer fabrication, but then the main focus of that is main focus of the next section is going to be how do I take this chip, the piece of silicon, and then connect it to the substrate or through the motherboard. How do we do all these bondings? What are these interconnects, as we call them, and what are the different types of interconnects that we encounter when we look at electronic products? After that, we are going to go to what we call the second level of packaging, which involves motherboard. How do we have this multi-layered, this thin motherboard which has 4, 6, 7, 8 layers of wiring traces within them? How do these different layers of wiring talk to each other when required, and also or when not required, how do we prevent crosstalk? We are also going to talk about a little about connectors, and finally, the third level of packaging where it goes into a system. The second half of the course will be about looking at the reliability. What are the mechanical stresses that this product encounters as it is switched on and switched off during its performing life? Thermal management. Most of the failures, I would say more than 70% of the failures of electronic products and systems can be attributed to thermally induced failures. All these devices generate heat. How do I remove that heat so that the temperature is kept below the allowable threshold limits? We are also going to talk about some of the physics of failures. Why do these devices fail? What are the failure modes, failure mechanisms, and also is there a way I can predict the useful life or the reliability of these products? Okay. So, as you can see, electronic packaging is really a vast multidisciplinary field. It requires expertise not just from electrical, but from mechanical, from manufacturing, from materials, from chemical, and so on and so forth. Okay. So, in this course, we are going to get an overview and feel of the roles of these different disciplines in this vast field of electronic packaging. I would just end with a little on a lighter note. I spent quite a bit of my career at Intel, and a question that I frequently used to face is, Anand, you are a mechanical engineer, what are you doing in Intel? So I hope at the end of this course we will all appreciate that the mechanical engineer also has an important role to play in the semiconductor industry. So I look forward to having all of you in the course, and together we will have a very enjoyable and enriching learning experience. Okay. What I would like to do now is invite one of the stalwarts in the field of electronic packaging, Professor Chris Bailey from University of Greenwich. He is also one of the vice presidents of the Electronic Packaging Society of IEEE. We will hear a little bit about what electronic packaging is and the importance of the field from one of the stalwarts in this area. Thank you.
Hello, my name is Chris Bailey. I'm from the University of Greenwich in London in the UK. I'm also Vice President for Conferences for the IEEE Electronic Packaging Society. I've just spent 2 weeks here at IIT Kharagpur, and I'm very impressed with the innovations and the technical work taking place here in electronic packaging. It's also given me the chance to investigate the actual size of this sector in India, and some interesting figures that in 2015 the size of the electronics manufacturing and packaging industry was 70 billion. It is predicted to rise to 200 billion by 2020. So this is a growing area, and I see it as being very important for India going forward. What is packaging? Well, we heard some comments on that just a moment ago, but packaging is very important from a consumer electronics product like your mobile phone to an aerospace system, an avionics system. The lifetime of a mobile phone may be 5 years, and an avionics system 20 years. Packaging underpins this in terms, and it's not just the physical packaging, it's also the design tools that underpin this. Understanding electromagnetic behavior, electromagnetic compatibility, electromagnetic interference, thermal management, critically important, given so many failures can result from thermal management temperatures. And also then using this data to predict the reliability of these products. It will be electronic packaging that defines the electronic products of the future. I look forward to attending this course, and I look forward to you joining me. Thank you.